Good evening, ladies and gentlemen. Shortly, we will start our special track session. So please turn on your camera, stay with your best position, and be ready for that. Assalamualaikum warahmatullahi wabarakatuh. Good evening, ladies and gentlemen, and welcome to the keynote session for the special track of Process Science and Data Analytics ISICO 2021. My name is Ika, and I will be the MC of the session. First of all, I would like to welcome Professor Jan Mendling, our keynote speaker of the day. Good afternoon, Professor. Thank you for your coming today. Okay. And also, Bu Mahendrawati Erawan. Good evening, Ibu Mahendra.
Hi.
I hope that you are doing great. And also, I heard that Pak Muja also joined this session. So, selamat malam, Pak Mujahidin. Great, thank you. So, the change in our environment, emphasized even more by COVID-19 pandemic, has brought a hard sign for us to consider our contribution to the society and to the world that we live in. We need to bring together the multidisciplinary effort to contribute to the achievement of Sustainable Development Goals, or SDG, by 2030. At the same time, BPM has received interest from researchers across many disciplines, including computer science, industrial engineering, and also operations management. However, the focus of BPM to date has been the interplay between strategy, people, and also technology within an organization. BPM now has various topics to discuss. Therefore, in ISICO 2021, we conduct a special track of BPM, which is Process Science and Data Analytics, with the topic of Cognitive Diagram Understanding and Task Performance in System Analysis and Design. This session will be broken down into several agendas. We will start the session by opening by the moderator, and then it will be followed by the main session, including 70 minutes of presentation and 40 minutes of Q&A session. After that, there will be an announcement of Indonesian BPM Association before we close the special track session. Now, let's move to the first agenda. But before that, I would like to introduce the moderator of our session, Bu Mahendrawati Erawan, PhD, the Associate Professor at IS Department ITS Surabaya. She studied Industrial Engineering in ITS before continued her Master of Science in Manufacturing Engineering and Operations Management. Operations Management and Manufacturing Systems in the University of Nottingham, UK. Then she obtained her PhD in Manufacturing Engineering and Operations Management in the same university. Now, she is a co-founder of Indonesian Business Process Management Association, or IBPMA, and also lecturer at IS Department ITS Surabaya. Previously, she has worked as research associate in the University of Nottingham, working in a special project called Value Improvement through Virtual Analytics Collaborative Enterprise, or VIVAC, a large European Union-funded framework SIS integrated project. Bu Mahendra has led various research projects, such as Framework for Business Process Management Implementation in Indonesia, and also Framework for Process Mining Implementation to analyze and evaluate ERP-based business process. Recently, she has published her research with the title of Profile-Based Cluster Evolution Analysis, Identification and Detection of Similar Clusters and Migration Patterns based on students' course-taking patterns and performances at IEEE Access. She has also published 2 books. First, Supply Chain Management in 2017, then Business Process Management, the Concept and Implementation in 2018. Now, without further ado, please welcome Bu Mahendrawati. Time is yours.
Thank you. Thank you very much, Bu Ika, for the kind words. And really welcome Professor Jan Mendling. It's a very good opportunity to have you here with us today. And welcome to all the audience. I will be your moderator, And really, I will just read out Professor Mendling CV and then let him really go through all the presentation, and maybe if he can take a question and answer for interaction, that would be okay too. Just something that I need to mention as well. If you have a question throughout the presentation, you can put it in the link that the organizer will put in through the chat. Okay. Now, can we please open the CV? I would like to read out. Okay, so it is a great pleasure for me to introduce Professor Jan Mendling, and he is the Einstein Professor of Process Science with the Department of Computer Science at Humboldt University, zu Berlin, Germany. And Professor Mendling obtained his PhD in Economics and Business Administration from Vienna University, Austria. And then his diploma in Business Computer Science and Business Administration in University of Trier, Germany. He has a lot of role. First, he's also the department editor for Business and Information Systems Engineering Journal. He's the board member of the Austrian Society for Process Management, co-founder of the Berlin BPM Community of Practice, and he's also part of the IEEE Task Force on Process Mining. At the moment, he is also still in lecturing in Vienna. I wouldn't try to pronounce this, and a guest professor at University of Liechtenstein and at University of Lubmin. Okay, I'm not a very good, and then a guest professor of Cologne International Summer School in 2015. Next slide, please. And Professor Mendling is also has published in so many different journals and articles, and he's the winner of Best Forum Paper Award and also the runner-up for Best Forum Paper Award. These are selected information that I would like to read out, but there are so many things that he has also done. But in the interest of time, I would really like to hear from you, Professor Mendling. The time is yours.
Okie doke. Thank you so much for this kind introduction. Salam alaikum is what I still know because it's very international and used in many languages, but I cannot offer any specific Indonesian language knowledge. I hope that I have the chance to learn some more in the future. So welcome from my side. In Europe, it's around lunchtime and we have a nice and pleasant day here. I hope this is also the case for you guys in Indonesia as well. I'm very glad for this honor that I can give a keynote speech at your conference. And I'm very glad also that we are now more in touch with several researchers from Indonesia, with Mahendra and other colleagues. And if there's Hamza Ricci somewhere in the audience, I give him a great greet as well. So what I would like to focus on today is one of our recent pieces of research. We are researching business processes from various angles, and that is partially a question that relates to business and business studies. We try to organize things around processes in a well and systematic way. And often also that means we have to think about how we use information systems in order to help us to organize processes well. And in this way, researching business processes is also a question of computer science. So, important at various stages of managing processes in the design phase, in the analysis phase, in the implementation phase are models. We're making use of models to support us to systematically conduct many of these management activities. And these models are often diagrams as we use them. That means they are visual models, and the term diagram emphasizes this visual character. And around this visual characteristic of models, we have seen a huge amount of research over the last decades with partially contradicting results. And partially also from our experience and our experiments in this area, we felt there was a need to reflect upon this large body of work in a systematic way and try to organize it. And this is what I would like to discuss with you today, together with my co-author Monica, who is a postdoctoral researcher at Vienna University of Economics and Business. We have tried to organize this large body, and the result is a framework that helps us to understand the cognitive effectiveness of these diagrams along the various steps of system analysis and design. So that's kind of the focus for today. And I wanted to illustrate this a little bit with a starting example. And before turning to that example, actually, I would like to ask into the audience, who's around? Yeah, so I'm curious to learn very briefly a little bit about you guys. And to that end, please go to the chat window. And I have some small questions, and maybe you can just type an answer for yourself to this question, and then we will have all these answers running through the chat window, and I get a little bit of an idea of your backgrounds. Mm-hmm. So let's have a look. Anybody in the audience who would say, do you like models? Yes or no?
What type of models, yeah?
Any type of design models.
Probably have a different type of models in their mind. Okay. Hamza said, yes, I know.
Yes, exclamation mark. All right.
Okay, well.
All right, that's good to read. Not really, all right. Maybe I can prove you wrong. That is actually a very interesting topic. But great to see that, that we have several enthusiasts about models here in the audience. Second question, that's more specific. Do you think models are useful? Sure, you can like things, but they can be of no use at all. But when it comes to models, do you think they are useful for design, management, implementation, etc.? All right. Yes. Okay. Good. Good. I see. Anissa is saying, I believe so. So we will discuss this in more detail. Maybe I can give you some more arguments.
What kind of model? See.
Next
she doesn't like mathematical model. I know her.
Oh, okay. Okay, it depends. That's a very good answer. I come back to that. Because then in the end, the question is why and in which circumstances are models useful? And you don't have to write no longer things here, but that will be the question that takes me to my next slide. So if models are useful, if we assume them to be useful, we have to understand why specifically they are useful. And that will give us an answer to this question upon which does this usefulness depend? And indeed, it depends on several factors. So let's have a look. Also providing some clarity, what kind of models am I talking about? And there are various kinds of models. And I'm talking here about what we also call diagrammatic models. So it means models that are also at the same time diagrams. And that, first of all, leads me to a very foundational distinction. We can represent information in different forms. Often we use text as a way to represent information, but we can also make use of diagrams to represent information. And these are two different kinds of information, two different representations with which we can capture essentially the same content. And this is what this slide is trying to emphasize. We have on the right-hand side a piece of text, and this piece of text explains us how a particular process works. You can imagine that there's a hotel, and in a hotel, there's a process defined for room service. And that means if a guest is asking for something to be delivered onto the room, then there's a procedure of how that is organized. So on the one hand, you need to organize that the right drinks or the right food is actually physically brought to the room, but also all of this needs to be invoiced to the room, and all of this actually needs to work well, needs to be well organized. So, and if you look at this piece of text on the right-hand side, you are actually left with, let's say, no other way of accessing that information as if you sequentially, sentence by sentence, read through that text. And that's different when we try to capture that information by the help of models. The models that I'm talking about are models such as the BPMN model on the left-hand side. And this is a diagram that represents this information by the help of different types of shapes and boxes that are connected with arrows, and all of this together explains how the process works. In order for you to understand how this process works, you have to have some preliminary knowledge of what these circles, boxes, arrows, etc. actually mean. Yeah. So, but if that is the case, for instance, Mahendra is joining me in the discussion about this process, let's assume that she does not speak perfect English as she does. I could show her that diagram, and she could understand how this process roughly works. Yeah? So even let's say if people do not speak the same natural language in a perfect way, this is a way of actually explaining things in a precise way. So, and what is interesting now, exactly what you see here on the left-hand side as this diagram can be represented as text and the other way around. So it means actually when you want to discuss this process, you have the choice if, let's say, if you go into a meeting and either show that diagram or you put a piece of text. Yeah, so it means exactly the information that is in the text is also in the diagram and the other way around. So there are even automatic techniques by which you can translate back and forth. And this is the reference that I put here on the left-hand side. So it means what we see here, when we need to discuss complex matters such as a business process, we can either describe them as text or we can describe them as diagrams. But even more complicated, even if we decide that we want to represent matters by the help of models or diagrams, we can do this still in different ways. And this is what this picture here is trying to allude to. So we have here twice the same diagram. That means the diagram on the left-hand side only has boxes and arrows, and the same diagram is replicated on the right-hand side, but now with colors emphasizing certain aspects of this process. And the usage of colors here is applied in a systematic way, such that it is actually meant to help a person looking at the diagram to more easily see its structure. If you, for example, go into the middle of this diagram, you will see that there are two elements with yellow color. Both these elements are yellow because they are corresponding to each other, like an opening and a closing bracket if you write a mathematical formula. And in this way, you can see, okay, around these yellow elements, there is a certain component of this model that belongs together. That means in this way, you can create an understanding what are the building blocks of this model, and it makes it easier to read and understand it. Yeah. What you also may recognize here, this diagram is, let's say, maybe not represented in the most perfect layout. It's difficult to spot, but actually it goes, let's say, in two columns. So the first column from the red element at the top goes all the way down, and then there's a jump up again, and then it goes down again on the right-hand side. And if you would actually would want to show that to a person, and you have more space, you would actually try to make sure that it is the same reading direction from the start to the end. So this is also here not the case. So you see there are a lot of, let's say, factors by which you can influence how these models are presented. So it's actually not a question about a model yes or no, but it is a question about how this model is organized. Yeah. So and in this way, well, many things can be varied in order to be effective or not effective. So, and that was kind of the key observation when we started to work on this topic. In case this is of more interest also for your research, there's a recent paper that summarizes all of this that I'm going to discuss over this session here. What we are happy about is that this paper is actually open access, so you can just find it on the internet and read maybe into more details if you're interested. So, well, why is this work actually important on understanding what are the factors that influence the cognitive effectiveness of such diagrams? The answer, let's say, lies in what was recently published around models. And one of the most recent works before our article was actually published and accepted is a paper by Jan Recker and colleagues. And they essentially emphasize the representational character of diagrams. The terms that they use is the term script and grammar. So script is, let's say, you can take it as synonyms here. So script is the same thing as a diagram, is the same thing as a model. So here, but people partially use different terms. What they try to discuss and what they felt to be interesting is that that models are not only used anymore as where people in retrospect try to document what they have understood about a particular domain, but also that they are more and more used actually to drive behavior and to drive what systems are doing in particular digital domains. And what I found always striking about several of the earlier works is that I always felt that there's an important point missing, and the important point that I try to highlight here is that in this conceptualization that they come up with, they kind of miss, in my opinion, the elephant in the room, but at least they give them very little emphasis. And that is the question, and it's a little bit hidden there on the third level, which kind of objective, which kind of tasks are people confronted with when they make use of diagrams and models. Yeah, and that is by itself, let's say, to a certain extent funny, because in many definitions of what a model is, you find that very explicitly. When people say, well, a model is a certain representation of a particular part of the world, where the content of that model has been selected with a particular purpose in mind. Yeah, so that means the purpose, the task, the objective is right there in the definition. But I don't know, for some strange reason, the last 30 years of modeling research does not talk much about which tasks are we actually faced with, and how these characteristics of these tasks, and how far they make models a suitable way for supporting them. And this is what I try to emphasize also with this work here. And in our recent article that I mentioned, with this article with Monica, there is one central diagram in there that explains our framework. And I have this framework here, but I want to, let's say, explain you that framework from the right-hand side to the left-hand side. And in the paper, of course, you see it presented from the left-hand side to the right-hand side. But I think what is the key is actually reading it from the right-hand side. And reading it from the right-hand side gives a strong emphasis to tasks. That means when we are confronted with, let's say, business process management, when we're confronted with system analysis and design, and the particular task of setting up an information system, there are different tasks that we have to face that are concerned with design, that are concerned with requirements analysis, etc. And depending on the characteristics of these tasks, we can more clearly see if models actually make sense or not. And it's actually sometimes that these characteristics of some tasks are as such that it is exactly what you guys earlier said. It depends. Yeah, so that means for one task, it can be that that a model is very useful, while for another task, the same model can be actually be much less useful as compared to other representations. Okay, so let's assume I'm talking now here about task processing. You can imagine that this is a task that you as an analyst are confronted with the question, what are the requirements of this new information system that I have to implement in my organization? Yeah, so that could be a task that I'm talking about here at this stage. So depending on, and then you can actually approach that task and ask yourself, well, how do I organize my working as an analyst around that task? And what we know from cognitive research is that humans take larger tasks and they step-by-step decompose them into smaller tasks, and then they step-by-step work on these smaller tasks and resolve them, and then bottom up again, they puzzle together the different solutions that they've found for these smaller tasks, and in this way, step-by-step, they establish a solution from the larger task. And that's a very foundational principle of human problem solving. Yeah, so this is nothing that we invented here. Yeah? But this is actually how it works. Yeah, so against well, in order to work on these tasks, we also need to maintain an understanding of the domain in our mind in order to be able to address these things. But the principle is like decomposition, what we often find. And that means the way how actually our brain works is that, let's say, a larger task is observed, and this is interestingly, it's a little bit of a computer metaphor that is also often used by cognitive psychologists, that the so-called central executive, so this is some part of our brain that controls attention and problem solving, that this is actually taking care of that. Yeah, so it helps us to identify different subtasks, but not only that. On the other hand, it makes a difference if, let's say, a person like Mahendra is facing the task of analyzing the business process as compared to a first-year bachelor student facing the task of analyzing a business process. And that has to do with means ends knowledge that may be there or may not be there, depending on what is the expertise of a particular person in a particular domain. So it means, for instance, for Mahendra, then it would be easy to identify and see that, there are these different departments, there are these different activities that have to be done. So let's look at them and create a BPMN model. While a first-year bachelor student may actually be fully overwhelmed because this means ends knowledge is not yet there. So they don't have yet experiences. So and all of this is available in the long-term memory, and that kind of, let's say, defines, let's say, a first context of how these tasks are being worked on. So the question is now, how do diagrams come into play here? Because like with any types of tasks, we have information needs. And these information needs can be fed in different ways. And one way is to present this information that is required for particular tasks as diagrams. And if we do so, we benefit from this information to be presented as diagrams when actually the semantic processing of that content is facilitated in an efficient and effective way by help of actually showing it as a diagram. So that maybe, for instance, if we have such a flow chart for representing a business process, we may actually much quicker see what are the different steps. We also see what is the order of the different actors that are involved. We also may see where can things get stuck or where may things get delayed. And all of this, which is semantic processing, may benefit from the fact that actually this is explicitly shown, for example, in a diagram. But also that does not come without context. So we need to have an understanding of the domain. I refer to this hotel room example. Maybe some persons who have been working in a hotel have a much richer understanding of what could actually happen to this process than a person who has not worked in a hotel. That's one part. That is what we call domain knowledge. And there's modeling knowledge as well. Yeah? So if a person has been teaching and served as a lecturer presenting process analysis concepts, sure, you know what the BPMN elements are, while also here in this case, a first-year bachelor student may still need to learn this. Yeah? So that means also modeling knowledge is required. So how does information actually come to this semantic processing level? That means we need to actually process a diagram along two channels. That is the so-called visual channel and the verbal channel. Diagrams have visual elements, and these visual elements, like symbols and different shapes, have predefined meanings. As much as there's textual content also in diagrams, because, for instance, these little activity boxes that we have seen, there are pieces of text in there. Even if there's not like full sentences, there is processing of text as well. So that means diagrams are here then actually useful if on the very right-hand side of this chart, they actually provide a benefit for working on a particular task. So then, this is kind of the larger idea of our framework, and all of this, let's say, all the different components are not components that we invented, but it's components that we organized along this framework in order to emphasize this point where diagrams actually provide benefits. That means in comparison to prior research, you find very often that, let's see, researchers start from the assumption and saying, well, I like models, so let's see what I can research around them. That's a direction that we find very often in earlier research. what we try to emphasize here with our work is that actually we need to foreground the tasks that people are concerned with. And for these tasks, diagrams may be beneficial. And if they're beneficial, we actually eventually have to demonstrate that along the line, that, for example, somebody is able to come up with a better process analysis when diagrams are being used. So, and that means, let's say, kind of the point that I'm trying to make in a nutshell is as follows. So, pretty much as I've read in the chat when I asked you guys, well, it depends. So, depending on which kind of system analysis task you're facing, diagrams can be helpful if they serve the information needs of the particular task that the person is concerned with, and if they meet criteria such that actually the diagrams can be considered to be cognitively effective. Yeah, so, and this last point shines a little bit through these different examples that I gave earlier, but I try to discuss this with you a little bit more systematically. So I think here, Mahendra encouraged me to take questions at different stages of our session, and maybe this is a good point here to pause for a moment with this overall framework, and maybe there's one or the other question that somebody would like to ask around this already now.
Thank you. Well, a good introduction, and we already have 2 questions. So perhaps it's probably something that you will discuss later, but if it's okay, I will read it out.
Please, yes.
Yes, the first one is from Anissa, Ibu Anissa. She would like to know, I am interested to know more about how a CogniDia framework, well, actually, Ibu Anissa, would you like to ask your question directly?
Yeah, hi.
Hello.
Sorry, it's quite early here, but I'm not sure. Yeah. Hi, Ibu. Thank you for the time. Thank you, Prof. Jan. I'd like to know more about how the framework, the CogniDia framework, incorporates social setting. The previous one, it says something human or social setting. I'm not sure what the words are, but do you think that probably the framework have considered the behavior of human? You say something about information needs, right? And how would that we put that as an important element in the framework? Thank you.
Thank you so much for that question. I think this is a very good and useful question because it is around the boundaries of the framework that we are presenting. And indeed, it's a good point that, let's say the tasks that we are looking at are, of course, often tasks that are located in a larger social context. Yeah, so we do not address this here in our framework. So it means essentially, let's say the cognitive perspective is often around the single person working on a particular task. And that means once that person is interacting with other persons, things, of course, get even more complicated. Yeah, so we did not consider this. Aspects that are important in a, let's say, in a setting where, let's say, a project team is working on a particular task are concepts that are referred to as, for example, shared understanding. So that means in how far do the persons that, for instance, work in the project team have the same understanding of what the particular task is about and what, let's say, the context of this task is about. And diagrams have actually been shown that they can be helpful of facilitating such a shared understanding. The term that is also used in that context is that, let's say, a diagram of how a particular process works. And then you have, let's say, all the people that work together in that process, and they look at that together and they start discussing how can we improve that process. We would describe that as that there is an external representation. So it means there's a representation of that process outside the mind of the people that are involved, and they can share this representation to create a shared understanding. Yeah, so that is an important concern that actually is then relevant for a larger group of people working together. Yeah, so we do not discuss this too detailedly in our paper here. It's one of the points that we identify for future research.
Happy, Ibu Anissa?
Yes, that answered my question. Thank you very much, Prof. Yan.
All right. Can I read two more?
Sure.
All right. The second one is from Hatma, who said that he doesn't really like model. Let's see. BPM and Cyber Security. Actually, Pak Hatma, would you like to ask yourself, makes my life as moderator easier? No? All right. Please read it. Okay, BPM and Cyber Security. I am a PhD student and an aspiring cybersecurity researcher. Will learning BPM be useful for my future career as a professor or researcher in cybersecurity? Can I ask your advice, please? What is the future research direction for the BPM plus cybersecurity? Thanks a lot, Prof. Yan. And he said that it's noisy there.
Thank you so much. Yes, I think this is a very good question. Indeed, the topics are actually closely related. And maybe this is not directly obvious because often when we talk about, let's say, threats and challenges of cybersecurity, we think of them as technical challenges, but it's actually worse. And for the fact that it is worse, actually BPM is relevant because much of the attack scenarios that we see these days make use of social engineering, and that essentially means that, let's say, the weakest point in the attack vector are persons working in companies in different processes. And then, let's say, somebody's calling them over the phone and convincing them that there's such a dangerous situation that that they have to share with me their access code or credentials, because otherwise, I don't know, the company
that happens,
explodes.
and it happens in Indonesia a lot. Yeah. Yeah.
In any parts of the world. So in Germany, we also know these scenarios. And in this way, so this is often the entry into the IT infrastructure of a company that persons in the organization give away such critical information to somebody else. And some of the smarter attack scenarios are actually aligned with the business processes of that company. And that means when I have, for example, knowledge about who's responsible for the different steps of approving an invoice and giving a green light for a payment, then I can explicitly target those people in their sequence. And that means, for example, I would first try to, let's say, talk in that person who's actually preparing the invoice. And when that person is so weak to give me that information, I can actually do the same play with the person who is usually the one serving as the second signing person. And in this way, you have actually attack scenarios along business processes. So that means actually the process perspective is extremely relevant for much of cybersecurity.
Okay, thank you. One last one for this session. I think it's from Pak Hamzah. Please open your mic.
Yes. Hello, Jan. Been a while.
Hey, good to see you.
Yes, it's really a long time not seeing you. Anyway, appreciate the batik, but the batik was that?
Me too.
Yeah, just curious. I mean, starting from your last line in your previous slide, in the last slide, I recall that you mentioned that it is will be effective for cognitive somehow, if I'm not mistaken. The question would be, does it mean that diagrams should be best used exclusively for cognitive purpose? I mean, meaning that it's more like human-oriented or human-driven purpose to make its use optimal. Thank you.
Yeah, good point. Let's look at how models are currently used, and they are actually used at least in two very distinct scenarios. One of the scenarios is what you're referring to here, that you emphasize. Many of the tasks are done, let's say, by analysts, by humans, where humans do something with or around these models. Yeah, so let's say a description of a process. There is a completely different scenario where these models are being used for configuring IT systems, for example, or for automatically generating IT artifacts, and in this way helping the software developers of coming up with a running system. And these scenarios are quite different, and we're currently working on that. Our, let's say, proposition is that that this is partially an explanation why there have been so, let's say, inconclusive perspectives in the modeling research over the last years. Because if you foreground the model, well, you talk about models and you kind of well, you don't give enough credit that actually the models may be used, let's say, in a requirements engineering setting, in a workshop setting where people discuss and brainstorming over a process, and you throw that into the same basket with a scenario where let's say system developers have very specialized pieces of software where they have to create a BPMN model to make the system running. Yeah, so and I think that is also one of the things where the task perspective is helping to untangle these inconclusive research results, because they are very substantially different scenarios. And once we talk about making diagrams useful for humans, we have to consider this cognitive perspective. If we consider that the scenarios where we have to make models useful, let's say, for automation and such that computers can easier work with them, we have completely different criteria that these models have to fulfill, because then they have to be formally correct, and they have to have formal properties, which is, let's say, less of a concern if you do brainstorming with your colleagues. And therefore, these two scenarios need to be considered separately. Otherwise, we end up in this confusion that the modeling community has been over the last 3 decades.
Okay, right. Thank you.
All right. Okay, I think this is for the first session of question and answer. If you would like to continue, then it's fine too.
Yes, perfect. Thanks a lot for these questions. So let's try to recall. So I sketched this framework, and the emphasis is on cognition of an individual person. Yeah, so it means we try to understand benefits that a diagram or a model provides for a single person in working on a particular task. So, so let's look at this a little bit more concretely, and I want to give you a few examples that make these benefits more clear, and that hopefully also provides us with some food for discussion, where we can see, let's say, what is this rich spectrum of all these kind of factors that play a role here. And it's actually a long list of factors that we can actually look at. So the first really large question is, can we say anything more specific about which kind of tasks we are dealing with? And that is actually a very difficult task, because we can give answers to that question on different levels of granularity. And for the sake of making it not too complicated in our article, we have referred to a very generic framework of which kind of tasks we can identify in any sort of engineering research, and that is roughly shown here. What do we see here? So first of all, we see some boxes. And I start with the white squared boxes. And you see from the left-hand side, there's a box called usage situation. The next box is called requirements specification. Then we have design specification, and we have information system on the right-hand side. So it means much of what we do in business process management, in systems design, in software engineering, etc., is identifying a usage situation, understanding that it would be beneficial to have some information system in place. And then we step by step move from the left-hand side via the requirement specification, the design specification, to the actual system implementation. Yeah? What these gray areas here refer to is that let's say that we are, in different epistemological spheres when we look at moving from the left hand to the right hand side. Essentially, we build on a framework from the philosophy of science, and that is a framework by Karl Popper that distinguishes world 1, world 2, and world 3. And it means, in essence, world 1 is what he describes as the physical world, and often in systems design we also speak of the real world, whatever that is. Yeah? So that is the outside world in which a usage situation is located, and in which we actually want to have our information system be running eventually. So, and for moving along our way, we make use of knowledge artifacts. These reside in world 3, and these are in the middle here of this figure. That is the requirement specification and the design specification. And these are knowledge artifacts. That means they are created to capture some truth, if we assume that there is some truth about the usage situation and the eventual information system. And let's say, simply put, they're pieces of text, and we can discuss around these pieces of text, and they create some, develop some existence on their own once they have been written down. So it means any progress here in this process is then dependent on that something happens in world 2. That is the upper gray bar. And you see that in this world 2, this is what Popper calls the world of mental states. So that is, let's say, anything that resides in any of the brains of the persons who are here in this call, for example. And any of the tasks that we are concerned with, these are tasks that essentially humans do, either fully on their own, or at least partially supported by information systems or by some means of automation. And in this way, this is where we can actually identify the tasks. Then from this emerges a very high-level description of different types of tasks. And we see that these tasks are partially, let's say, obtaining a different flavor. So it means on the very left-hand side, the tasks are very open, from eliciting requirements, refining requirements, and it becomes more and more narrow when we approach the design specification and we decompose it such that the system is eventually implemented. It's becoming more narrow and more narrow, and it's getting more specific. And that means actually one way of discussing diagrams is actually to project it onto any of the tasks that we may identify along this process. The tasks that we can identify here, they have quite different characteristics, and we need to discuss which kind of characteristics are important for the task that we are facing. So it means roughly, if I would actually come up with a claim saying, well, models are super beneficial for eliciting requirements, then the requirements elicitation task is actually the context in which I could make such a statement, and it's the context in which I could actually research if that is actually making sense. So, and diagrams are now being used for many of the tasks along this system analysis and design process. The characteristics here of diagrams that we can actually observe here is that diagrams are mixtures of pictorial elements and textual elements. Some of them are highlighted here on the left-hand side in blue. You see here we have a BPMN model of a very simple business process. And that business process starts with us receiving an order. Then that order is checked for completeness. If incomplete, we progress through the upper branch of this model. If incomplete, we progress through the lower part of this model. You see that there are textual elements, and they describe actually with which concerns we are dealing with in relation to this. So there's text. There are glyphs. Glyphs are, for example, letters or textual symbols. You see here in this diamond-shaped element in the middle, there is a cross, or if you know a bit of BPMN, you will see that this is actually not a cross, but it is an X. And this X is actually the letter that points to the meaning of this being an exclusive gateway. So there's an exclusive choice here between either continuing with the upper branch or the lower branch here of this model. So then we also have different shapes. So the activities are represented as such quadrangles with the rounded edges. We have these circles. They represent different types of events in the process. And these can also be extended with ideograms. And this is what we see in the upper branch. This little envelope refers to the fact that information is exchanged here. And then finally, we also have lines. Yeah, so it means these are, let's say, the typical building blocks of the models, of the visual models that we're looking at when we speak of diagrams. And these are actually supposed to have some effect of how well we can actually solve our tasks. Yeah? So that means now we again see here our CogniDia framework, and our framework now helps us to discuss the different concerns that we have to identify and analyze when we try to identify if these diagrams are helpful and useful, if they provide cognitive efficiency. It means, let's say, simply put, the framework says, well, the diagram is cognitively effective if, and that's the first column, if it supports the visual processing well. Second column, if it supports the verbal processing well. third column, if it supports the semantic processing well, and fourth column, if it supports the task processing eventually well. Yeah, so that's roughly the type of argument that is uttered with this framework. Yeah, so and I will show you some examples of, let's say, what are specific criteria in each of these categories, and that hopefully gives some ideas of how we can do this well or what we can actually do wrong. So what is interesting about, let's say, from a research perspective here about this is that some of the parts of this cognitive framework have been largely ignored by prior research. Oh. If you see here onto this chart, the verbal processing has received very little attention in prior research. Also, the task processing is not so prominently discussed, such that we can actually, it's fair to say that research in the information systems area has been either largely on the visual characteristics of models or on the semantic characteristics of models, and these other characteristics have been largely neglected. So I saw that there was one person asking a question. Shall we take one or the other question?
Endang, I think she just raised her hand and then, no, I think it's just like trying out the reaction. It's working.
All right, technology works. That's good to see.
All right.
Okay, right. So let's look at a few examples. Yeah. So there are so many criteria that we found in the literature. At an extent of several hundreds, we categorized them such that we came up with 22 categories of criteria. And I want to show you a little bit of the most important. So let's first look at the visual processing. So there are largely 7 different categories of criteria that relate to visual processing. There's rich research in any of these particular areas, trying to understand how aesthetics, visual consistency, simplicity, pop out, different strategy of grouping elements, of different ways of how symbols can be designed in a nice or not so nice way, contribute that an analyst can nicely process diagrams from a visual perspective. Now I'll show you some of, let's say, the more established ones. And one of the most important ones is layout. Layout means that we can have the same elements of a model, but we can organize it differently how we position them on the 2-dimensional canvas. If you look at the model on the right-hand side at the bottom, maybe you will find that confusing. And if so, I'm happy to see that acknowledged, because that was actually the idea of creating this model on the right-hand side bottom. So it means actually for understanding that model on the right-hand side bottom, you have to follow where the arcs are going, and you see these arcs are then crossing, and they're overlaying, and they're pointing partially up and down and back and forth. Such that actually it's quite difficult to see what is the direction that this process is going. If you now turn the attention to the left-hand side, top of this slide, you will see a model that looks simple and organized. And if you want to double check, give it a second, and you will identify it's actually exactly the same model. It's exactly the same. The only difference is that the position of the elements and the arcs is different. And this is what one of the criteria here in this visual processing actually is emphasizing. You can do a lot with good or bad layout, and I particularly emphasize this to my first-year bachelor students because they partially let's say, they don't give enough credit to this usually. So they create their models, and maybe the arcs are not running perfectly, and then they usually think they are done. And I often emphasize actually, it is not an option. It's not optional if a model looks nice. A model must look nice. Yeah, so you must make sure that a model looks as nice as the one here on the left-hand side. Because this is the very early stage of the cognitive processing. Yeah, so and if you mess up things already at the visual processing stage, all of the other subsequent stages are affected, and in this way you get worse results. And this is something that you can easily influence as a designer. Yeah. So we also did ourselves some experiments around symbols. Symbols are also interesting to consider because at many stages we have the choice which modeling language we pick. And depending on which modeling language we pick, we get a corresponding set of symbols with them. And here you see 4 times the same model being represented with the symbols of different modeling languages. And on the right-hand side, this is the example that shows the BPMN version. And then here towards the left-hand side, you see other languages being used. So there's one with the YAWL language, there's one with UML activity diagrams, and an EPC model. Semantically, they're exactly the same. So the only difference is that they use different symbols. And then depending on which kind of symbols you use, it's much more difficult to spot which of the elements belong together and which kind of meaning they have. And the worst of the examples is the one that is the third one from the left-hand side. And that is the one with the small boxes, and where the boxes have some extension in the upper or the lower part with a triangle in there. And so in this little triangle there captures what is the splitting and the joining semantics. And you see it's all triangles there. It's all triangles in a corner of a box. And it's difficult to separate them and to distinguish them. Yeah, so if you compare that with BPMN, you have very clearly here this plus sign in this square, and you may have an X in the other elements. So this is actually quite easy to distinguish what is this element by itself, and what is this element in comparison to the other elements. Yeah, so and that actually makes quite a substantial difference. So let's look at the verbal processing stage. So that is some research that has received less attention than prior research. We identify that the clarity of the text elements and the effective presentation of the text elements plays an important role. I could show this. I could try to illustrate this a little bit with another example from a different experiment of our research. And what we tried to identify was, let's say, how the length of the text has an influence on the cognitive processing. So the model on the right-hand side, don't mind that it is German, but you see that each of the little boxes, all of them are meant to refer to an activity. And the one on the left-hand side only has letters. So there's Z, D, E, T, C, and so forth. Each of them separately referring to a particular activity. And on the right-hand side, you have partially a 3-line piece of text referring to an activity. In that experiment, we gave tasks to participants, and they had to identify if how activity Z is related to activity F. Yeah, so that was one version of it. And the same question was posed for somebody having the model with the text. If what is the relationship between the activity Empfängerauftrag per EDI in comparison to Prüfe Bonität? Yeah? And what we could see is actually simply for the fact that these pieces of texts were longer, we saw that actually cognitive restrictions come into play. So it means your cognitive capacity, if it requires less mental space to store and identify the activity labels, it frees mental capacity actually for more high-level reasoning. So it means actually the semantic processing worked better when the texts were shorter. Yeah, so it was one of the effects that we could actually observe here. There's also plenty of research around the semantic processing. The semantic processing has two levels. There is some semantic processing that can be affected by, let's say, overall criteria that are associated with the modeling language, and then also with the diagram itself. And also there's some interesting findings that we can observe. So the semantics then actually, and maybe let's look again here at this column. You see in long-term memory, there's modeling knowledge and domain knowledge. And that is an interesting experiment that our colleagues conducted. They took essentially the same models and they created models that were structurally the same for a version that was designed for a library versus a version that was designed for how neurotransmitters do something in the brain. Yeah? So, and you see on the left-hand side all of these terms from hippocampus to neurotransmitters to glucocorticoid, etc., etc. Words that I do not know. Maybe you know them if you have medical experts in your family, or if you have also some medical knowledge yourself. But I do not know them. Yeah. So if I read this model on the left-hand side, much of what happens in my brain is wondering, what do these terms mean? Or even just like simply trying to speak out the term correctly in my mind. Yeah. If I have the same model and instead of neurotransmitters, we're talking about somebody owning a book in a library, that is something that I can much easier handle. Yeah. So that means actually the background domain in which a model is located plays a role, and this is what our colleagues here could nicely show in their experiment. So, and also, let's say how semantically the models are composed is of certain relevance. They also varied in another experiment how explicitly certain information is represented in models. And you see the difference between these two versions of the same model is that on the left-hand side, reservation is shown as an explicit entity here. It's also on the right-hand side, but it is kind of hidden as it is subsumed into the relationship between service provider and customer. You read there, participates in reservation, for example. Yeah, so it's mentioned, but it's not so prominently shown. There are ontological guidelines that would actually say the version on the left-hand side is the good one, and the version on the right-hand side is a bad one. And in order to substantiate it, they conducted experiments and could actually exactly show that effect. Then, of course, what makes things more complicated is that many of these criteria can be relevant for one individual model. And I heard that at least some people in the audience who know business process management and our business process management book. And in this business process management book, there is the example that you see here on the left-hand side. And there's an interesting story with it, because the model here on the left-hand side is a model, when you see it for the first time, you wonder, how can somebody ever come up with such a strange model? And I can confess that actually it was not us, but we took this model because one of our colleagues had this model, and it was created in a project in a company. Yeah, so it was a real company where real analysts were creating this model on the left-hand side in this, let's say, crazy way, as you see it here, with this all of these gateways and these overlapping arcs, etc. So you do not really see what's really going on here, but it looks super complicated in this part in the middle. So, and I also use this example often in my courses, because it's always a pleasure to see how students are surprised when they then eventually discover that the same thing here on the left-hand side that looks so complicated is the same thing as the one, the very nice and simple model as on the right-hand side. Yeah, so it's simply the content is better organized, and then you have a nice model, and you can much better understand what's going on, and can focus on it and on the content, and you're not left with puzzling it out how things actually work together. So that means that these different processing steps, from visual, verbal, and semantic, they play an important role. Which kind of information makes it into your brain as a mental model of, let's say, the process or the system that you actually want to understand and solve different tasks about them. And actually, indeed, on the task level, there has been not much research. There's some discussion around that the diagram should fit the users, that the diagram should fit the goals and objectives of a particular analyst, and that the language should be appropriate to the problem. I want to highlight a bit a piece of research that Hamza knows best, because that was, to what I understand, the first experiment that systematically said, well, we don't need to change the representation, but we also need to additionally change the type of task that we look at. And maybe there are interesting things that we will observe. Yeah, so in Hamza's work, there was a textual description of a particular process. That was actually here where goods are physically delivered, and there were certain steps and procedures that had to be taken such that the goods could be taken in by the receiving company. Yeah, so we had a piece of text that it was one version, and that there was a diagram describing exactly the same process, but by the help of a visual representation. So, and our idea was, well, we might actually manage to identify different tasks where there are some tasks where the diagram works best, and there are other tasks where the text works best. And see what we found. Actually, it came out actually very nicely. That there were actually tasks that were very much benefiting from the visual search that was facilitated through the visual models. These are the ones that you see on the left-hand side. And if you just pick, let's say, the first box here, you see on the one axis, it's the estimated marginal means of the participants. So it means it was essentially some sort of score that they could obtain by answering to these questions. And they had BPMN versus text available. And you read that on the second axis. Yeah, so it means, in essence, you can read it as follows. Those guys that had the BPMN models scored much, much better than the guys who had actually the text. Yeah, it means that type of recognition and search task benefited very much from the visual diagrams. Yeah? So because you could actually directly identify the different elements And for particular search tasks, this is super helpful instead of when you need to read through the text. And I now move towards the very right-hand side. There you see the lines work exactly in the opposite direction. We have again BPMN and text, but now you see here that actually the point is much higher for the text as compared to the BPMN. And that was actually a task that was a so-called CLOSI test. And CLOSI test means you explain to the participants the process, and then you give them a piece of text with blanks. And they need to write in the correct words at the particular positions where there is a word missing in the text. And there you see, when there is such a task, they were doing much better if they have earlier seen a textual description of the process instead of a diagram description. Yeah, so it means what this experiment in this way very nicely showed is that you can actually identify tasks that very much benefit from text, and there are tasks where you very much benefit from diagrams. So and that is actually a clear answer that it depends, makes a lot of sense, and we need to clearly understand what the tasks are about when we choose if we would want to use text or different types of visual representations. So what can we do with this? In this paper with Monica, we discuss various implications and directions for future research from this cognitive framework. There are several questions that would be interesting to address in future research regarding the visual processing. We know from other streams of cognitive research that heuristics, effects, and biases play an important role with picking and foregrounding different pieces of information, and partly also ignoring other pieces of information. There's not much research that has been done in this area, but it actually would be very interesting. If there is somebody in the audience who has ever seen or read the book Thinking Fast and Slow by Kahneman, this is exactly a good starting point for any of such research. Second point, the verbal processing. Also there, we have not seen much work. On the other hand, there's a rich spectrum of earlier research on theories of reading. And these theories of reading are very strongly emphasized on reading of text, of pure text. Yeah, and diagrams have text, but text is not alone. Yeah, so and that raises all kinds of questions in how far these prior theories on reading can be adapted, or to which extent, or if they have to be extended or modified. So also there, a lot of interesting questions in this. Then there's semantic processing. Exactly this nice question that we had already earlier is around diagram cohesion and sense making out of models. Yeah, so we spoke about the social context of this, and in particular when different persons are working with the same diagram, then there are all kinds of questions that can arise in terms of diagram cohesion, content-wise, and in how far different persons can establish a shared understanding of such diagrams. Yeah, so that means, partly in that context, we can build on theories of sense-making, for instance, but also on formal ontologies and representation theory. Also, there are very interesting questions in this regard. So, and regarding the task context, also there, we can broaden this framework in particular towards this social direction. And what is very important here is a better understanding of tasks. Yeah, so I think in that regard, we took a pragmatic choice where we framed our work in the tasks of the system analysis life cycle in order, let's say, to clarify the relevance around these different stages. But from a research perspective, there's a very strong question there. What is a suitable level of granularity to look at tasks, such that we can discuss which diagrams contribute where to a good understanding? Yeah, so for the younger researchers, plenty of things that you could do in your research. So, and that means before closing, I can try to emphasize that one of the things that is interesting to consider is that we can also look at this work from a practical angle. And from a practical angle, we observe that we can translate what we find here in a way that we can give recommendations to practitioners. And I think that is the most practical side of this work. In essence, each of these categories of criteria that we identified map exactly to guidelines that can be formulated around them. So it means, for instance, we identified that for visual processing, aesthetics play a role. Yeah, that's very easy to reformulate as a guideline for practitioners when you say we need to ensure that the diagram is aesthetically pleasing. That was actually one of the things that I tried to highlight with one of the examples. Also, in the same way, you find some such guidelines for the other categories, and these can actually help to create models that are nice and helpful, and that turn out to be cognitively effective for the persons using them. Right, so well, there's plenty of things to be discussed, plenty of things to be researched in future research. And if one or the other person in the audience, and this is now a little bit of an advertisement, is researching BPMN and which kind of impact BPMN has on various levels, I can recommend you this call for papers of a special issue that we will have in the BISA journal. There's still a little bit of time, so the submission deadline is the 7th of January. And if you are interested, if you want to get some early feedback on an idea that you may have, please approach me. We are looking forward to nice submissions here to the special issue that looks at the impact of what the BPMN language had on industry research, etc. So it means instead of, let's say, summarizing, I would like to leave up this list of questions, maybe as a trigger for our discussion. So there are plenty of things that can be discussed around all of these different areas. You also can identify these 4 cognitive steps again that we have in our framework. And I look very much forward to further discussions with you guys.
Thank you, Jan. All right, we have quite some questions. Yeah, the first one here. This is a good thing and also the bad thing. I think everybody knows that you are a professor in business process management, so everybody kept asking you about BPM. So
that's completely
could
fine.
We could we assess the performance of the blockchain systems for supply chain by using BPM?
Yes. Question is how. So I think the question is, how are these 2 topics related? And we have been actually doing some research on blockchains for supporting business processes. if you search, you will identify some key papers that I've also been cooperating with others. In essence, the connection is as follows. One of the key problems that we have been facing with organizing processes in the past is that we typically have automated, we typically have defined system support for a process within our own organization. Yeah, so it means if we think back of one of the examples that we have seen, there's a delivery process. I can organize this in my company if there's a delivery coming in and which kind of invoice that triggers, etc. So a problem is, of course, many processes are complicated, and processes are specifically complicated when several partners are interfacing with each other. And usually any business process has some inside and some outside perspective. And in the past, we have not been able to integrate external partners well. Let's say the state of the art is using EDI messages and sending them around. Yeah. So the point is now when we adopt blockchain as a technology for representing inter-organizational processes, there may be exactly the benefit that this technology can provide for business processes. And so our research together with Ingo Weber from TU Berlin and Marlon Demas group from Uni Tartu was to a good share focused on the question, how can we design processes, let's say, with the standard BPM tools that we know, like modeling processes with BPMN, such that we can then actually execute them on the blockchain. And many of the solutions are of the kind that we still model the process as a BPMN model. And then we can actually take that model and generate the system components that will run on the blockchain. And in this way, we can actually facilitate that the engineering and the design of such blockchain-based systems that support business processes is being conducted in a more efficient way.
Okay, thank you. For the next question, I think, Tara, would you like to ask yourself?
Thank you, Ms. Mahendra, for the opportunity. Thank you for presentation, Professor Jan Mendling. My name is Wafda. I'd like to ask regarding modeling, what is your suggestion for researchers when modeling a system so that they didn't end up with too detailed or too general models? Thank you.
Yeah, this is a very difficult question, actually. Let's say we looked at the different stages of the design process, and if we consider, let's say, the very late stages of design, this question is much easier to answer than if you look at the very early stages, where it is about identifying requirements. So at the very late stages, you essentially working, for example, with a system like Camunda. So that is a BPM system. You model the BPM process, and it will be executed by that system. So it means, in essence, everything that you do with your BPMN model, you directly project and reflect upon how the system will look like. And this is something where actually the granularity of the system that you want to create dictates how your BPMN model is supposed to look like. If you compare that, you create a BPMN model for, let's say, very early requirements engineering, for maybe an exploratory analysis. This is much more difficult because you have so many options to choose the level of granularity. So I think, let's say, in the light of, let's say, all of these many choices available, one of the things that can provide you with some guidance is that you can first focus on the level of granularity such that you capture the handoffs between the different persons that work in the process. Yeah, so that means if, let's say, if you do not have any other more specific focus, it's good to model, let's say, who's doing what in which order. Yeah, so it means that you can see, here person A is doing something in the process, and then work is handed off to the next person B, who does something else.
Thank you, Professor, for the answer.
Thank you.
Okay.
Ms. Mahendra.
All right. Now, this is an interesting question. I have a similar question, actually. Ibu Reni, would you like to ask yourself?
Yes, Bu Mahendra, thank you for the opportunity. So I find it interesting that you said that the length of the text influences people's performance in diagram understanding. However, in the example you've given, it was actually symbols, X, Y, Z versus explanatory natural language. So I was wondering if you do mean understanding in terms of the relationship between tasks only, or does it include in terms of understanding what needs to be done or the process that occurs? I was thinking that it might be related to RQ7, the appropriate level of granularity, and RQ8, the amount of text. But I want to comment that Empfangeaufträge via Telefon, das ist ja kurz, cannot be shorter, I think. So are you saying that
we're lost.
It is that is starting a contract, a request via telephone, if I'm not mistaken. So I think that's just 3 words. Could you be any shorter than that? So are you saying that actually it is better not to use text at all, and it is better just to use identifying symbols and just put the text below the diagram? So
annotation.
Yes, annotation. So thank you.
Yeah, super good comments. Thanks a lot. So many, let's say, many pieces of an answer. So I think the first observation is exactly right. What you're saying here. So the let's say the way how the experiment was designed was artificial. Yeah? So we chose making it so artificial for the sake of internal validity, such that we could actually identify the sharpest contrast. Yeah? So in practice, of course, it's a little bit more difficult because exactly as you say, you may have the choice, let's say, to formulate a label, let's say either with 2 words or 4 words, yeah, and then it's not so clear anymore. Yeah. So what is possible, and what is also related, let's say, to the conclusions from that experiment is that it makes sense to consider various guidelines for labeling the different elements. And there are some labeling guidelines. We've also worked in that area that emphasize the shortness of the labels, and that emphasize particular grammatical structures. So if, for example, in English, the usual recommendation is to use verb phrases. That means you start with the verb and then you put the corresponding business object to which that verb refers. And in this way, you usually also arrive at a label that is shorter, as, for example, if you use nouns to refer to the action. Yeah. So, but that clearly is something that is of relevance and that needs to be considered. And I also, let's say, I see some relevance of, let's say, of this guideline to put labels short. Also, I see sometimes, usually more with, let's say, early bachelor students that tend to write more into these labels than actually more experienced analysts. And well, let's say it's not so uncommon that, let's say, students who are first-time modelers that use labels of 2 or 3 lines of text, where actually an experienced analyst would actually use 1 or 2 words. Yeah. So there's clearly a relevance to that, and it makes it increases clarity. It gives a clear emphasis on what are the important entities that we are discussing about with that task, and it helps actually to support any types of, let's say, higher level tasks that actually follow them after parsing the text.
So yes, thank you so much for the answer. And well, I was just going to ask. So of course,
Please.
you explain more about this in your paper, and if I read your paper, I will be able to get the references for all these things. Yes, I find it like very interesting that there's actually like a body of research just talking about how long a label should be. So very interesting. So thank you so much, Professor Mendling.
Vielen Dank. Thanks a lot.
All right. Okay, now I have to do the translation for the next question. Oh,
right.
No, actually. Does the CogniDia framework explained by you earlier has been used in a company or organization? If yes, could you please tell me how the framework affect the company or the organization?
Good question. It is the CogniDia framework is recent theoretical work. That means it's theoretical, so it's let's say too abstract to be directly applied in a company setting. And it's recent, so it means we also have not had yet the chance to. So it means so far, no. The work is, let's say, on the other hand, it has a practical foundation because many of the previous experiments and insights that we build upon have actually been applied in practice. Yeah, so it means if you go through the guidelines that you that I showed in one of the last slides, you see that actually these guidelines have at least partially already been applied, not based on our research, but in other research before us. Yeah, so there is indeed also some external validity to all of this work.
Okay. The next question is, I'm sorry, I forgot to mention everybody's name, but this is from Pak Bayu Waspodo. He asked, how can a diagram make it easier for users to communicate with the current process so that the modeling of process becomes smoother? Is there a way that can help the user to understand the various diagrams? Does the use of certain languages also affect?
Right. I start with the last thing. Yes, language actually matters. Yeah? So it matters along, let's say, the different characteristics that we have seen. There are some languages that have, for example, nice symbols. And if they have nice, understandable symbols, this helps. There are also some languages that have, let's say, suitable and precise semantics. Also, that of course helps. Yeah. So that means the communication is then affected by different types of diagrams. Let's say if you consider, let's say, those persons to be a language community. So it means, let's say, if you are in a situation, let's say you work, let's say, for some large corporation, I assume like in many other countries, the Indonesian telecommunications provider would be a very large company. And if, let's say, if they agree for the whole company that everybody there learns BPMN, in the business analyst teams, then actually this joint knowledge of that language makes it much easier for them to understand and to work together in projects. Yeah, so that is one of the effects. If let's say a group of people is equally well trained by using certain types of diagrams. Things are more difficult if that is not the case. So we see often the challenge, for instance, in process analysis projects, that this is the key challenge in the process discovery phase, that there is a person like an analyst, that could be me, that could be you, talking with some domain expert about how the process works. And then you put this into a BPMN model. And then you need to check if the BPMN model is right, but you cannot just simply show the BPMN model because your counterpart person doesn't understand this.
Yeah.
So that means you have to take your model and you have to
translate it again. Yeah.
Speak over that model such that the person understands the natural language that you're using. The person understands Banda Indonesia, what is in the BPMN model. Yeah, so. That means it's, I think the most important factor here is, does this circle of users who want to communicate, do they equally know well the modeling language? Yes or no?
Okay, right. We still have one last question. I would like to invite Bariki. Would you like to ask yourself? This is a long one. That's why I think Bariki, you should ask yourself.
Okay, thank you, Ms. Mahendra and Professor Yan. So my question is, in developing a business process model, sometimes it's hard to determine the granularity of the task. For example, in actual day-to-day activity, there are several tasks within a task. If we don't include the subtasks, and in the future we want to do a qualitative or quantitative analysis on our as-is business process model, it could lead on having ambiguity on our analysis. On the other hand, if we include all the subtasks to the models, I think it could be too complicated to develop and understand the models. So how can we get the right granularity when we want to developing as-is business model?
Yes, very much to the point. Yeah, so this is really a difficult problem, and this is a problem that not only we have as working with business processes. But it is a key essential problem of any sort of cognitive research on tasks. And there are whole communities of research that focus on task and techniques such as hierarchical task analysis. And it's exactly as you say. So any task has subtasks. And if you go then, let's say, all the way down to the smallest kind of task that you can think about, it is actually, I don't know, a single neuron in your brain triggering something somewhere else. And this is, of course, too fine granular for us to work with. So I think one important level is indeed this level of granularity where we can see where is the handoff from one person to the next person. This is something that we always need for a business process. But often this is also too coarse granular for certain types of analysis. And for instance, let's say in my university, there are some processes that are paper-based, and these are usually the annoying processes. They exactly raise this, they exactly point to this problem. Because if, let's say, from a conceptual level, I would identify what are the particular tasks. It is, for example, that the task is for me to, let's say, to fill out a form for a travel reimbursement, and then actually sending that to the responsible next person in the accounting department. The point is, of course, these are, let's say, the things that really have to be done for that process. But there are many things happening in between, because if it is a paper-based process, I would need to print out my form. I would need to put them into an envelope. I would need to put them into the department mailbox, where then somebody from the internal mailing service would actually pick it up on a certain part of the day. physically transporting it to the central mailing delivery service of the university, and then actually bringing it to the next department. So it means actually, let's say, the only guidance that you can obtain is that you, exactly as you say, when I do want to do such a quantitative analysis for that process, then this is relevant. Yeah, so it means based on the purpose with which you create that model, you will find some guidance what has to be in or what has not to be in. And for this reimbursement process based on paper, in my university, if I would do a process analysis, this would be relevant because this internal mail physical delivery takes time, and it's even error prone. Yeah, so that means the overall process is really affected by this, and therefore it has to be considered. Even, let's say, from a conceptual perspective, you might actually first of all ignore it because this is not really what really people do in the process. So the purpose, that's indeed the purpose and the task. So if you want to analyze, let's say, the speed of the process or the error proneness, then you need to have everything in there that actually contributes to time and errors, for example.
Okay, thank you very much for the answer, Professor Yan.
Thanks so much for the question.
All right, I think in the interest of time, I think I have to stop taking the more questions. And first of all, I'd like to thank you, Jan, for sitting with us here for almost 2 hours now. Now I trust that you can go on until 4 hours. Right. So let's give an applause first for our excellent speaker. And we also have something that we would like to share with you. If you were here, then we can give you a lot of things, but we can only give you this. Thank you so much for your wonderful keynote. And also, I would like to take this opportunity to also introduce that we are inviting all of you who are interested in business process management or any related research. We know now that Professor Mendling is the professor in process science, for example. So it's not just business process, but also other related area. We are inviting you to join us in Indonesian BPM Association. So I would like to invite here the co-founder as well. Here is Professor Bernardo from Hankook University of Foreign Studies. And there are also Pak Hamzah Richi from UNPAD, and also Pak Bayu Waspodo here from UIN Jakarta, and also we have UISI here, Yogantara. And if you are interested, you can join us through the sites. At the moment, we only have a humble site. So is there anything else? No, just that. All right. Then anybody who are interested, you can contact any of us, myself and Bu Ika from ITS, and also those co-founders that I mentioned. Thank you very much, everybody, for joining in this session. It has been a real pleasure. And we have here our head of department, Dr. Mujahideen. Would you like to say a few things?
Yeah, thank you, Mr. Jan. I hope we can meet again in another event. Thank you very much.
Okay. Would you like to have last word, Jan?
Yeah, thank you so much. It was great fun joining this session. I can fully endorse this Indonesian Business Process Management Association initiative. Mahendra is humble enough that she did not mention that she will soon finish the translation of the BPM book to Indonesian with several co-workers. So this is great to see that the BPM topic is taking off in Indonesia. And I believe also this topic is so relevant in all kinds of regards. It will help your departments in establishing strong ties with industry, and it will also help the local community, the local businesses to grow. We've seen this here also in our countries, and I look forward to see this topic growing over there in your country.
Okay, so there's the link in the chat room. If you want to follow and have a look, then you are most welcome. Now we come to a conclusion of this special track. I think we will have a photo session, as always. Please bear with us. Maybe there are a couple of pages. Who is going to help me with the photo session?
Let me do the things. I can do that.
All right.
So how many box do we have to do? Oh wow, it's up to 5 screens, I suppose. So let's start with the first screen then. Are you guys ready? 3, 2, 1.
Wow.
Okay. I'm gonna take twice for each screens. Let's step to the next one, the second screen. 3, 2, 1. Okay, bear with your smile. Don't let it close. Okay, we're coming to the third one. 1, 2, 3. Right.
There is good special effect, Pak Hamza.
Oh, that's too bad. I leave that, you know, the right bottom part is still, you know, the sign of that we have we did some printed still here. Okay, anyway, the second last one. 1, 2, 3. Right, and the last one is the fifth screen. There you go.
Okay, thank you very much. He's very, very helpful with the photo. Thank you very much, Pak Hamza. Okay, I think I will now return to Ibu Ika, who will close this session.
Okay, thank you, Bu Mahendrawati, and also Professor Mendling. Such a wonderful and great topic to discuss today for the special track, and I can't wait to read fully for the CogniDia framework and guidelines. But unfortunately, we are reaching the end of this session. So I would like to again thank you for Professor Jan Mendling for coming today and delivering such a wonderful topic to discuss for the special track. And also thank you very much for Bu Mahendrawati for moderating this special track session. And also thank you for all the participants for being active to ask so many questions and also difficult question for Professor Jan Mendling. I would like to inform that tomorrow we will have other agenda for the ISICO 2021. So we will have remaining 2 keynote speakers and also workshop sessions at the evening. So the ISICO 2021 tomorrow will be started on 8 o'clock. And also the keynote speaker will be followed up after the opening session, and then the workshop will be held on 12 o'clock in the afternoon. So now we are reaching for the end of the session. I would like to say thank you for all the participation and see you for the tomorrow session for the ISICO 2021. Bye.
Thank you, Jan. Thank you. Thank you, Mahendra.
Thank you very much, Jan. I will be in touch. Bye-bye. Thank you.
We'll keep in touch.
Yes.
Bye.
Thank you. Bye.
Goodbye. Thank you, everybody.
Bye, everybody. Have a great weekend, guys.
Yeah. See you tomorrow.